Hello everyone, welcome to Geeks for Geeks Python channel. My name is Utkarsh and welcome to this series, this session which is based on socket programming. This is part 5th. So I welcome you all to this session. We will start in just a moment. Let me just check the audio. The series? Yes. So the audio I've checked, it's working fine. Video is also fine. Yes. So welcome to this session. This is part 5 on this series, which is on socket programming. We are discussing socket programming. So in part 1, part 2, part 3, part 4, we have discussed how to implement sockets as on a very low level. Okay, what low level means, it's not like it was easy. Actually, low level means it was difficult. So low level code means it is very close to the system uh, programming, right? How systems are designed, how systems are built, it is very close to that. So low level programming means that. So we explored sockets in Python, and we explored the low level part of it. Okay, so we discussed the client server architecture in part 1. If you have not seen those part 1, 2, 3, 4, I would recommend you to stop. After this video, you can watch this video and go back to part 1, 2, 3, 4, or you can first finish part 1 to 4 and then come back to this part so that you have clarity. We have discussed sockets in great detail in part 1 to 4. Okay, we have discussed how to implement sockets on a low level using Python. Then in the second lecture, we discussed about some parameters related to sockets. In part 3, we have discussed about the file IO with the help of socket file input output between two sockets. And in part 4, we also discussed about some parameters related to object communication between client and server. Okay, so that is how we have concluded the socket's low level design till now. Okay, so now what does as I told you, what does low level means is basically you are exploring the depth of how sockets are built. Okay, you are not using any API, or you are not using any obviously, if you see, if you implement sockets in C as a C language as compared to Python language, then it would be different from Python, right? In Python, you have lots and lots of abstractions and encapsulations, right? In terms of what you implement in C, it is very different from. So that is why Python is high level language, right? And languages like C, C++, these are low level languages. Why? Because we interact with the systems on a very deep level in these C and C++ languages. In Python, we make use of the high level language code, right? So that is not very close to how systems are designed. So that is why we say Python is a high level language, and languages like C, C++ are low level languages. But when we implemented sockets in Python, we implemented it using low level code of Python. Okay, so that how sockets are defined, sockets are also defined as high level and low level, right? In Python, though Python is a high level language, but sockets also can be classified into categories like high level and low level, right? So low level would be how the socket API is given as part of documentation, right? So you go to the very basic, you implement socket from your own, and then you handle all the threading, all the client server architectures, how client would connect, how client would disconnect, how server handles multiple clients, and all those things, right? So this is low level. Why? Because you are implementing every every functionality by your own, right? With the help of the official documentation of sockets given in Python, right? So that becomes your low level design of sockets in Python. But today we will be exploring one such library, which is, so let me just write the library name, which is ZeroMQ. Okay. So we will be exploring the functions in this ZeroMQ library. So that now this is basically a messaging kind of library which is built on top of sockets. Okay. So if you can recall from the first lecture or the first part, what we implemented was basically a client server architecture, right? So we had a client, we had a server, and the purpose was that the client will send the request and the server will send the response, right? So client will send the request and server will respond. And what are these request response? It's basically data, right? So client sends some data to server, then server accepts it, and then server responds with the data, whatever the client needs, right? So this is what we implemented. We have been implementing throughout from part 1 till part 4. Okay. So that is how we have explored sockets, right? So ZeroMQ is also kind of doing the same thing, okay? But it is basically, you can say it is more like a messaging protocol, messaging library, okay? So why I'm saying it's a messaging library, we will we will get to know about this as and when we explore more about ZeroMQ. But what ZeroMQ gives the functionality is to implement different socket based architectures. Okay, so it gives us the functionality to implement different socket based architectures. Now what are these different socket based architectures? We will one is this client server, which we have been implementing from part 1. One is this, it can be publisher subscriber, it can be push pull, or it can be some other, right? There are basically 4 architectures. We will explore these in detail, but as of now we are just focusing on client and server architecture. Now, what issues we faced when we implemented sockets with the help of the low level design, using the low level code functionalities? What issues we faced? So first of all, in the first lecture itself, we faced the issue of handling multiple clients, right? So how we tackled that? We tackled that with the help of threading. And what we did, so for each client, we said that we will handle it in a different thread. Okay. And that client's socket was basically handled in a different thread. Okay. So we implemented that. That was working fine. We could accept messages from different clients, right? There was no issue. But most of the applications that we built in our real world scenarios are much more complicated than just sending normal string data. Okay. So the applications or real life applications that we see on a day-to-day basis are much more complicated than just handling few clients, right? You cannot just handle few clients on basis of text message exchange. There are a lot more complications, and there are a lot more I would say there are a lot more complications involved in handling such architectures. Okay, as you build some or as you take up the problems of real life applications, things become very complicated, right? So first we will understand what are these complications and what how ZeroMQ will help us in overcoming those complications. Okay, so we have, as of now, we have understood that ZeroMQ gives us is a library, and it is I mean, it's a great solution to implement client servers architectures or publisher subscriber architectures, uh, and it's very scalable and it's very fast, and it basically handles everything for you under the hood, right? You just have to use their API in the choice of in your choice language. It can be C, it can be C++, it can be Java, it can be Python, it can be Ruby, it can be Golang, it can be anything, right? So the choice of it offers, basically you have choice of over 30 plus languages, right? So it exposes its API in 30 plus languages. It's a library. It gives you the functionality to implement client server or different kinds of socket based architectures, and then you can just use it, consume it, use it in a right manner to just scale your app. Okay, so we will first see why do we need this library, right? So I'll go to this page, and let's just read through why do we need ZeroMQ. Okay, so if you can see, I have highlighted this. We want to study about why do we need this MQ, right? Okay, so let me just zoom in so that you can read. Yes. So why do we need ZeroMQ? So we will read this, then we will go back to our discussion again. So the first point is that how do we handle the input and output, right? Does our application block, or do we handle input output in background? This is a key design decision. Blocking IO creates architectures that do not scale well, but background IO can be very hard to do right. So we have explored this blocking thing in the lecture one, right? Whenever the server accepts any connection from the client, it basically blocks, right? We have explored this when we were implementing sockets using the low level code, right? When we were using the low level API of sockets, right? So we have seen all these problems. It becomes very difficult to do these to handle these input and outputs, right? One is blocking condition, then there is background input output condition. Background output input is basically handling threads, handling different clients in a thread. Blocking IO means you are not handling different clients in threads, but you are just simply blocking. It's basically like synchronous, right? Until and unless one client finishes, another client is not handled, right? So that is why it is saying that blocking IO creates architecture that do not scale well, right? If you have multiple clients which are connecting to your application, then you can't have blocking IO, right? Because you have to serve multiple clients at the same time. Your application should have this functionality that it lets connect different users to the same server, right? So blocking IO doesn't scales well, but if you do background IO in terms of threading, then there are lots and lots of complications in terms of how do you handle those clients, and then how are those clients exited, and there are different conditions which can arise, right? Then the second point is that how do we handle dynamic components, that is pieces that go temporarily, right? So I mean, when do we close the connection? How do we connect the client to the servers? How do servers connect with different servers? So how do we after how many seconds do we do reconnect if the connection is failed? All these things, right? So these are the dynamic components. So, and then the third point is how do we represent the message on the wire? So basically, we implemented a protocol to handle text messages properly, but the main thing is that is when the data becomes more complicated, then you will have to come up with different algorithms, right? We created one such algorithm for handling the string data when you are communicating textual data between client and server. So we have done that, but as and when your data gets complicated, obviously your handling of the message on the wire also becomes complicated, right? There can be issues related to read, write, and buffer overflows, right? So these are some of the problems. Then how do we handle messages that we can't deliver immediately? So if the message delivery has failed, then what do we do with that message, right? And how do we store them? So all these issues. So basically, there are some issues that are listed over here. You can go to their official documentation and read about these things. So as you can see, they have listed about some 15-16 different kind of issues, right, which we might have if we implement sockets using the low level API. So that is what ZeroMQ overcomes. Okay, that is what ZeroMQ helps. That is where ZeroMQ comes and it says, okay, you don't have to worry about all these features and stuff. We will take care of that. You just focus on the application and how you want to create the application. Okay, so ZeroMQ comes and I will just give you the overview of what ZeroMQ is. So ZeroMQ is also known as all these names, looks like an embeddable network library but acts like a concurrency framework. Okay, so what it means is it's basically a network library, but it acts as it is basically built on the socket technology, right? It is built on sockets. So it gives you sockets that carry atomic messages across various transports like TCP, UDP, multicast. This we will understand. Okay, so you can connect sockets end to end pattern like fan out, publisher, subscriber, task distribution, and request reply, which is client server. So it is fast enough for to be fabric for clustered product. It is asynchronous IO model. Okay, so this is very important. The model used in ZeroMQ is asynchronous. Now, what does asynchronous mean? So we will understand what does asynchronous mean. So let's say you have your server. Okay, now this is your server, and server is basically it's there to serve the multiple clients, right? Now let's say you have client 1, you have client 2, you have client 3, and you have client 4. Okay, so now in in asynchronous, what it means is the server can serve these client requests in parallel, okay, at the same time. So I mean, what I try to mean is, in if if the model is not asynchronous, then first client 1 will be served. Okay, then after it serves client 1, it will go to client 2. Then after client 2 request is done, it will go to client 3. Then after client 3 is done, it will go to client 4, right? So this is synchronous. This is synchronous model. It will accept the request from client 1, wait for some time, then it will go to client 2, then client 3, then client 4. But let's say you have 10,000 users which are connecting to your application at once, and each serve is at least taking 1 second. Okay, let's even take 1 millisecond, or let's take half second. Okay, so half second per client means you will have 5,000 seconds just to serve the, you will have to wait, I mean the 10,000 number of the client that which connects at the 10,000 position will have to wait 4,999 seconds. Okay, so that is not what you want, right? If you want it, what you want is all the 5,000 clients should be able to connect on the server, and then the server should just wait for some time and then serve all the clients at once, all the 5,000 clients at once, right? So what basically we want is how your server handles one client in synchronous model. We want that functionality for all 10,000 clients at once. Okay, so then it becomes asynchronous data model, right? So that is what it is written over here. It's asynchronous input output model, gives you a scalable multi-core application built as a asynchronous message processing task, right? So it has a score of language APIs and runs on most operating system. So it can be Windows, Linux, anything. If you have the access to the API, it basically runs on every operating system, right? So it is these are some of the features: universal, smart, high speed, community is great, the guide is also good, it is multi transport, right? And if you see the list of the companies which use this library, which use this framework, there are some top-notch companies which use this framework. Okay, starting from Microsoft, Samsung, AT&T, Spotify, Facebook, DigitalOcean, Auth, Bitcoin, Jupiter, Mongrel to Gina. All these are big companies, right? So they all use ZeroMQ for somewhere for their application for whatever purpose. Okay, I don't know for what they use, but they use it definitely. That is for sure, right? So if something is being used by all these big companies, then that means that this is a good framework which gives you the scalability. Okay, why I'm stressing on this library is because when whatever applications you create using sockets, they need this scalability. Okay, what I mean by scalability is, when your application grows in numbers, when the number of users grows for your application, then your application should be able to serve all those in parallel, right? So if so, for example, if you consider websites like Indian Railway, how much traffic they handle on a day-to-day basis, right? If they go down for even 2 hours, that becomes a huge loss for them, right? So it has a big impact when your application grows in scale, right, in terms of number of users. So that is why if you implement all those things using the low level design, then you will have to take care of way all the different parameters and things and scenarios, which is very time consuming. It is very difficult. I have seen very top-notch developers, even they fail in these in implementing sockets from scratch. Okay, so it's very difficult. So that is why we use that is where ZeroMQ comes. It makes things difficult as easy for us, and you can create applications which can even serve up to 1,000 connections at a time. Okay, I'm just giving you a number. Like even the simplest of the applications that we create using ZeroMQ will be able to serve at least 1,000 number of clients at a time in parallel. Okay, I'm not saying that it is handling 1,000 connections on a daily basis. I'm saying it can handle more, up to thousands of connections at in parallel at a single time. Okay, so that means if you create whatever we will create a very simple client server in today's lecture. But even that has the if you host it as an application, then that application can handle, I would say, at least 1,000 some number, I mean some 1,000, 2,000, 3,000. It has the capability. Just a single socket server has implemented using ZeroMQ has the capability to process up to thousands of clients in parallel. Okay, so that is a huge improvement in terms of speed and scalability, if we consider what we have implemented from lecture 1 to lecture 4, right? I'm not saying you should not explore sockets on a low level design, on a low level API basis. That is also important. Why is it important? For you to understand whatever is written in this library, or whatever, how ZeroMQ functions. So you have to have basic knowledge of sockets. You need to have basic knowledge of threading. You need to have basic knowledge of socket communication, TCP, UDP, and all these things. Okay, how publisher subscriber model works, what is publisher and subscriber, what is client and server. So to implement, I mean to understand how even ZeroMQ works, you need to understand the sockets on a low level API, right? Once you understand the sockets on a low level API, it will become somewhat easier for you to understand how ZeroMQ works. Okay, so what we are how we focused how we have seen this tutorial is basically in first four parts. We understood what is socket and what is it doing. Okay, so that is what we have done, and we have also explored some low level implementations or some low level task that can be done on a client server architecture, right? After we have done that, now we face the issue of scalability and distribution of our application when it goes to the users, right? And when the users numbers grow, then we will face some issues. So to tackle those issues, we are coming to ZeroMQ. Okay. So enough of discussion. We will come back to our discussion again. So we have seen it is asynchronous. Uh, Let me just write over here. So it basically implements uh, sockets, all right, and it is asynchronous. It is threaded IO, in background. So these are all the key features which ZeroMQ gives us, and these are very important. If your application needs to scale, then these are the main key features which you should implement, and these are very difficult to implement. Mind my I mean, just take this as a note. It becomes very difficult once your applications become complex, right? To implement asynchronous, to implement threaded input output in background, to implement multiple clients, right? Handling multiple clients, right? And so all these things, it becomes very, we have already seen why do we need ZeroMQ, right? All these parameters like dynamic components, handle input output, handle the message on the wire, then message not delivering to the server or client, then handling message queues, like these are some of the topics which are very difficult to implement, right? If you go, I mean, whatever we have discussed till part 4, if you go one level higher to that, you will have topics like select and polling. Okay, so there you will get the concept of messaging queues. Okay, so then you will handle message queues, then the lost messages, then what if we need different network transport like IPv6, right? Then how do we route messages? Then how do we write API for another language? Okay, how do we represent data so that it can be read between different architectures? And how do we handle network errors? So these are some of the uh, things that we will need to handle, right? So all of these are implemented in ZeroMQ, right? I mean, not directly, but some in through some way or through your implementation. Some are like they come pre-handled, like asynchronous threaded input output in background, multiple clients to connecting to the server, that is handled. So if the server is not started, but still client can connect to server. So all these things, different architectures, that is given. But obviously not all of the functionalities are implemented, because some have been kept reserved so that you can use it programmatically, right? So now what we will do is we will implement a very simple client server architecture, client and server, and we will implement two clients and a server so that we can see how to use this, right? So let's get started without any further delay. I will create a simple Python file, and let's wait it to get loaded. Yeah, so let's implement our uh, server on this client. I'm implementing the server, okay, client server. So this is the server script. So I'll import time. I will import ZMQ. Okay, now this ZMQ is ZeroMQ. Okay, if you can pip install ZeroMQ and then you can import it like this. Now I will create a context equals ZMQ dot context. Now what is this? This is just a container to keep all the sockets which you create. Okay, now I'll create a server socket. So socket equals context. This is how you create the server socket. Context dot socket. Okay, and inside socket you will pass zmp dot rep. Now what does zmp dot rep mean? it basically means that you are this is a response kind of socket. Okay, so what a response kind of socket, it basically means it's a server socket. Okay, so it's not ZMP, it's ZMQ, right? The library name is ZMQ. Okay, so socket is done. Now we will bind this socket dot bind. Now remember, you use bind on the server side and you use connect on the client side. Okay, always remember this thing. Bind we use on the server side, connect we use on the client side. Okay, so here we give the local port and everything. So TCP / then anything. Then I will give the port number. Let's take 5555. Okay, so it's basically like localhost 5555. Okay, now I'll give the while loop so that it can read for incoming messages. So now it should start reading message equals socket dot recv. We have done this already in the part 1 to 4. Okay, so now I will print the message received. I'll give f string, and inside f string I'll give rec received request, and inside receive request I'll pass message as a f string. Okay, so let me close this. Okay, I have to give brackets here. Yes, so now it's printing. Now I'll give time dot sleep for 1 second, and what I mean by sleep is basically you can implement some other logic. Okay, so that is basically the idea behind time dot sleep. Like instead of time dot sleep you can do something. Okay, do something, or I have implemented that with time dot sleep. Then again socket dot send underscore string. Now I am just giving back the message to the client which connected that world. Okay, so my basically client will say hello and my server will say world, right? To multiple servers, to multiple clients, whoever connects. Okay, so that's it. That's my server side. It's as easy as this. Okay, you just create a socket. You just create a context which is holder for container for your socket. It contains all the sockets you create. You create a server socket using zmq.rep. You use bind on the client side, server side. Then you enter a while true infinite loop, and you receive the message, you sleep or you do something, and then you send back the string. Okay, so now I'll create one more file which is basically the client. Yes, open. Yes, so I'll save the first script as server, right? So Control S, let me choose the folder. Okay, so I'm saving it as okay, save as, okay, it got saved as module 1. Okay, not an issue. So we will this is module 1. Okay, now module 2 will be my client. So I'll first save this module 2. So I'll save client, this as client.py. Okay, client.py. Yes, so this is saved now. Now I'll implement the client side, right? So again import the library which is ZMQ. Okay, then create the context which is basically the container for all the sockets that you create. ZMQ dot context, right? You call the context, you create the context. Now you can just print that connecting to the server. I should give it as string, connecting to the server, right? So print is done. Now I will create the socket object, right? Socket equals context dot socket, and inside this I will give ZMQ dot req. Okay, so in the server side it was ZMQ dot rep. Okay, it's not er. Okay, let's see. Yeah, in the server side it was ZMQ.rep. On the client side it is ZMQ.req. So rep is basically response because server is sending response, and on the client side it is req, which is request because clients are sending request, right? So it's a convention, you can just give that. Okay, so socket dot, now I'll connect this socket to my server. So socket dot connect, and inside this I'll give TCP using the TCP network, local host, same thing, local host and 5555 port number, right? On my local machine I'm running this on port number 5555. So now I will take a count equals 0, and inside a while loop I'll just increment count by 1. Now what this count is doing is basically, count is printing the number of times it has received the message, right? Like it has sent first message, second message, third message, right? So that thing. So now I'll just print f string. So sending request, and this, inside this I'll give count. Yes, so I hope we are connected. I think there was some connection. So you can see even on YouTube you can get disconnected sometimes. So you can just imagine how difficult it can be to implement sockets.
Yes, so I hope.
Yes, so it is working fine now. Okay, so we go back, we come back to our client thing. We have printed the sending request and inside that count, right? We have printed that. Now I will send the message from the client side. So socket dot send underscore string. The method is send underscore string, and inside that I will just give hello. Okay. Okay. And now because the server will also respond with the message, so I have to read that. So message equals socket dot recv. Okay, and then I'll just print using the f string received RECEIVED reply, received reply. Inside that I'll give message. Okay, so that is done. That's my client side. Now what we are doing, we are implementing a server which basically reads and then sends. I mean, we are doing the same thing but the order is different. On the client side we are first sending and then receiving. On the server side we are first receiving and then sending, right? This order has to be reverse, because if you send from client and receive I mean, if you don't receive first on the client server, then it will be an error, right? Because one should send and the other should receive. That is the architecture, right? So you cannot use send first. If I use client server socket dot send first over here, I cannot use socket dot send over here again, right? Because that will clash. So I use socket dot send string here, and on the server side I first receive. Then because after sleep of 1 second my server is again sending, that is why I am receiving on the client side, right? Okay, that is my server, that is my client. I'll save this. Okay, so now I'll run this script. So cd, like I'll navigate to the folder. Okay, let me just zoom in a bit. Okay, let's create one more client which contains the same code but has a different message which it is sending, right? Let's create one more client. So client empty module. I'll save this as client1, right? Client1.py. Okay, this is my client1, this is my client, or the first client. So I'll copy this same code and I'll paste it in client1 so that I can show you the functionality of multiple clients getting connected. Okay, so instead of sending hello, I'll send over here hello from second client. Okay, so the second client is sending hello from second client, and let's give it hello from first client in the first client. Okay, yeah, so my first client is sending hello from first client, second client is sending hello from second client. Server is accepting both and will send world to both of them after receiving the message. Okay, so now we will execute. So let me just zoom in a bit. Now cd zm, yes, so now py, my server is saved as module1.py, right? Okay, so it has executed, it is executing, as you can see it is blinking, so that my server is executing, right? Now what I'll do is I will open my second command prompt. First I'll zoom in. Yes, so this is my second command prompt. So cd desktop, this will mimic the second client, ZEROMQ tutorial, and then py client.py. So the client.py is my first client. Yes, so now it is executing. It is my client is sending hello from client1, so it is getting received from on the server side. As you can see, it is printing, and at the same time my client is also receiving world as the data, right? So as you can see, it is printing the request number, printing the reply, and on the server side also it is implementing the same thing, right? It is implementing the message which client1 is sending. Now let's open one more command prompt which basically will mimic the second client, or which will mimic the uh, multiple clients getting connected, right? So this is my second client. Let's put it over here just below this. So cd dex, I'll navigate to the same folder, cd zm, yes, this is my folder. Now my second client is saved as client1.py. Yes, so now if you see, this client is also sending data, this client is also sending data to the server. So now you can see it is receiving both the messages in parallel, right? It is first printing hello from first client, hello from second client, first client, second client, first client, second client, then again first client, then second client, then first client, then, so it is basically receiving data from both the clients, right? If I take one more, if I let's execute one more in parallel. So let me just zoom in a bit. Yes, this much is enough. I hope this is visible. So cd desktop, cd zm. Okay. Now, okay, because I don't have I'll have to create one more script. Okay, let's create that just for, until then it will keep running, so that we have, let's create a new file. Okay, so this is save as, let's save this as module client2. So client2.py. So this is my third client, but one of the client was just saved as client, so that is why this is my third client. So I will save it as client2.py. I'll copy the same code which is given in client and client1. Copy the same code, and here I'll say hello from third client. Yes, hello from third client. So now let's go back to our server and everything. This is my server. This is one of the clients. This is the second client, and this is the third client. So let's run it. pyclient client 2.py. Okay. And now you can see it is doing hello from first client, second client, third client, first client, second client, third client, first, second, third, first, second, third, and it is processing all the three clients in parallel, right? All the three clients are running simultaneously and can send requests to my server, right? So using this ZeroMQ, you can at least serve 1,000 connections in parallel using just this code which we have discussed today. Okay, we have discussed a very simple code, but this has the scalability up to thousands of connections in parallel. Okay, so this is the power of ZeroMQ. This is why top-notch companies like Facebook, uh, Bitcoin, Microsoft, and whatever companies we discussed in the starting, all these companies are using ZeroMQ, right? Why? Because it offers you this asynchronous input output on a client server architecture based on sockets, and your processing and everything becomes very fast, right? If even if I hand if even if I open 500 more, it will be able to, I mean, it also will depend on the network and your system configurations, right? So my system is basically i5 and 16 gigs of RAM, but so it's like decent, not too good, not too bad. But what I'm trying to say, it also depends. This all things also depends on the type of system that you have. But uh, what I'm trying to say is ZeroMQ gives you this functionality to, if you have chosen the correct network parameters, if you have that capability in terms of network and system parameters, then it gives you the functionality to, I mean, this will basically scale your applications for thousands of connections in parallel, right? And if you build on top of this, you have no limitations, right? So all the modern day applications which have traffics like thousands or millions of requests uh, on a daily basis or on a weekly basis, all of those applications can be created using this library, right? So if you see, everything is running. We have processed like till 180 over here, till 116 over here, and till 15 over here, right? So it's running perfectly. All of the clients are getting handled in parallel, right? So nothing is lagging, nothing is, and we are not missing any information. It is reading all the informations from all the client, first, second, third, first, second, third, first, second, third. Like, it is not happening. It reads only from first client and third client. It skips second client. No, that is not happening. If you see it, the order is getting maintained continuously. First, second, third. Then again first, second, third. Then again first, second, third. Then again first, second, and third. Right? So the order is maintained. So nothing is getting missed. All the communication between client and server is happening in parallel. Right? So this was a lecture, a very this session was all about exposing you to the ZeroMQ library and to expose you about the scalability and all the network related uh, parameters which are difficult to implement using the low level API of socket, right? So this was to expose you towards the ZeroMQ library and uh, its usage and the features that it offers, right? So all these features are very important when you have to design scalable apps, right? So for that purpose, just please consider ZeroMQ. Please read their docs. Please read some of the examples if you can. Read some of the architectures, and we will definitely scale from here as well, right? In terms of what we are discussing, we will discuss the different architectures. So today we have discussed the client server architecture. In the next session, we will discuss about the publish subscriber architecture, and then we will see how can we implement different things on top of that, right? So I hope you found this session useful, and please, I have only one request from my side. to all of you guys who are watching this video, it's a very genuine request that please like this video, post your comments. If you have any queries, please post them as a comment. I'll be happy to reply to any of you, right? It can be any doubts related to this session. It can be any doubts in Python in general. So if you have any doubts, just post them as a comment and I'll be happy to assist all of you, right? So that's it. And the humble request is that you please subscribe to our channel if you have not. Press the bell icon so that you get all the notifications regarding our videos. Please share this video, like this video, share it with your colleagues. If you are a student, share it amongst your friends. If you are a working professional, share it with your colleagues. So, and with someone who is basically trying to learn coding, who is trying to learn programming, right? So that basically gives us the motivation. It gives us the motivation to create such content for you, right? We will be creating such content for you, but if you do this small bit, this is the only expectation. If you do this, this basically keeps us motivated in the long run, right? So I hope the session was useful for you. I will see you in the next one. Until then, stay safe and take care of yourselves and your family, right? I'll see you in the next one.